The following is an example of a system of two linear equations in two unknowns. X plus y is equal to 10 and x minus y is equal to 4. Notice that 7 and 3 are the solutions for the system because these two integers satisfy both requirements. 7 plus 3 is equal to 10 and 7 minus 3 is equal to 4. Notice also that when you add them together, 7 plus 7 is 14, 3 plus negative 3 is 0, and 10 plus 4 is 14. 14 is equal to 14, and this is a true statement. Now, you need first the equation to be of the form ax plus by is equal to c, which means all the variable on one side and the constant on the other. You need two coefficients either for x or for y that are opposite of each other. Then you can add them. To eliminate one of the variables and then solve for the remaining variable. Y and negative y will cancel when we add, so let's add them. 2x plus 0 is equal to 10 plus 4, 14. Now let's divide both sides by 2. Since 2x is equal to 14, we get x equal to 7. 7 can replace x in either of the two. If we choose the first one, then 7 plus y will be equal to 10. We replace x by 7. Subtract 7 from both sides. Y is equal to 3. And the solution is the point 7, 3. When you cross two lines, they intersect at one point and one point only. That point is a solution for the system of linear equations. Now, linear change means that if you change one variable n times, the other one will also change n times. In other words, x is equal to a. If you double x, you have to double a. If you triple x, you have to triple a. Let me give you an example. X equal to 3, 2x is equal to 6. So this is the property that we're going to use to solve the system of linear equations. We have 3x plus 2y equal to 5 and 5x minus 4y equal to 3. We should notice that 2y and negative 4y can easily be eliminated because 4y minus 4y is equal to 0. How can we obtain 4y in the first equation? We have to use linear change and multiply the left side by 2 and the right side by 2. Notice that when we do that, the equality doesn't change. 2 times 3x, 6x, and 2 times 2y, 4y. 2 times 5, 10. The second equation stays the same. 5x minus 4y is equal to 3. Now when we add them, y will cancel. We're going to get 11x equal to 13. Divide by 11, x is equal to 13 over 11. Let's consider the next problem. We need to find both x and y of the system. Now we need to subtract 5y from both sides. Therefore, the equation will become 3x minus 5y is equal to negative 9. This is the form ax plus by is equal to c. We need that form in order to be able to compare it to the second equation, 2x minus 7y is equal to negative 17. We're going to take a closer look at 3 and 2. And the LCM between 3 and 2 is 6. We multiply 3 by 2. Now we need opposite sign so that the x term will cancel. Therefore, the first equation will be multiplied by 2 on both sides. And the second equation will be multiplied by negative 3 on both sides. Notice that 6 and negative 6 will cancel each other. We're good. Let's distribute. For the first equation, distributing 2, we get 6x minus 10y is equal to negative 18. For the second equation, distributing negative 3, we get negative 6x plus 21y is equal to positive 51. When we add them, the x terms are going to cancel, 0. Negative 10 plus 21, positive 11, 11y. And 51 minus 18, 33. Divide by 11. When we divide 11y by 11 and 33 by 11, y is equal to 3. We need to remember that 3x is equal to 5y minus 9. This is the first equation. And now we know that y is 3. We're going to substitute. 3x is equal to 5 times 3 minus 9. 3x is equal to 15 minus 9. And 15 minus 9 is 6. So 3x is equal to 6 divided by 3. X is equal to 2. So the solution is 2, 3. The point 2, 3.